Alright, problem 30. We have the integral from 0 to 7 of f of x dx equals 9, and the integral from 5 to 7 of f of x dx equals 2. Then we need to find this integral from 0 to 5 of the quantity 3f of x plus x dx. Okay, so we look at this, and the first thing that I would do is I'd start breaking this apart. So I know that the integral here of the sum is going to be the sum of the integrals. So I have the sum of 3f of x and x, and I have an integral of them. And what I can do then is say that this will be equal to the integral of 3f of x dx from 0 to 5. And we can use our given integrals up here to find that, plus the integral from 0 to 5 of x dx. And let's figure these out. So I have here a 3 times f of x, and this is a constant multiple, and I always like getting these constant multiples out of here, making it easier for me to see what's going on. So this right here will be equal to 3 multiplied by the integral from 0 to 5 of f of x dx. And I'll keep going with this. I'll bring down the other integral in the end, but this will then equal, notice I only have integral from 0 to 7 and from 5 to 7. 3 multiplied by the integral from 0 to 7 of f of x dx plus the integral from 7 to 5 of f of x dx. And you can also look at this as 3 multiplied by the integral from 0 to 7 of f of x dx minus the integral from 5 to 7 of f of x dx. So if this is the integral, if this is some sort of the area between the x-axis and the curve from 0 to 7, and this is from 5 to 7, positives and negatives in the integral sort of way, if I go from 0 to 7 and I subtract off from 5 to 7, or I go back from 7 to 5 as I showed up here, you'll end up with the integral from 0 to 5. And I know the integral from 0 to 7 is 9, so it's going to be 3 multiplied by 9 minus, I know the integral from 5 to 7 is 2, so this blue part, I'll come back and do the purple part shortly, is going to be 3 multiplied by 7, which is 21. Now let's take care of the purple part as well. We shouldn't forget about that. So we still should have a plus. And this one, we can just take the antiderivative and evaluate as we always have. So the antiderivative of x, this is the same as x to the first. We add 1 to that, we get 2. We divide by 2, so this is going to be the same as x squared divided by 2 evaluated from 0 to 5. And that, I'm just bringing it down, may as well use these lines we have already, keep everything valid. That's going to be equal to 5 squared divided by 2 minus 0 squared divided by 2. And 0 squared is 0, divided by 2 is 0. We don't even have to worry about this term. And so we're left with this plus 25 halves, plus 25 halves, all the way down the line. Okay. And we should know that 21 plus 25 halves. Well, 21 is the same as 42 halves. 42 halves plus 25 halves is equal to 67 halves, and it doesn't reduce. 67 over 2, and my answer choice is E.